Hi, fellow geochemists and geochemistry enthusiasts. Welcome to GeoChemISTea, the only podcast for people who love geochemistry with a side of tea. Our mission is to inspire future geochemists and to introduce our listeners to niche geochemistry topics. I'm your host, Sam Scher, and this month we're talking with Simon Bolster about geochemical technology innovation in the mining industry. Joining me today is Simon Bolster, an exploration geoscientist, regolith specialist, technologist, and a longtime advocate for fit-for-purpose geochemical methods. Simon has spent his career pushing the industry to understand regolith before sampling it, to design geochemical programs that suit the terrain, and to stop waiting months for results that should guide decisions in real time. He's been a pioneer in the use of near-surface geochemistry across deeply weathered terrains, an early voice in advocating pXRF workflows, and now a leader in bringing DetectOre, RockBot, and rapid on-site geochemistry into mainstream exploration. So Simon, welcome to GeoChemistry.
Yeah, thanks, Sam. Pleasure to be here.
Simon, can you tell our listeners a bit about your path into exploration and why regolith sampling and practical geochemistry became your core focus?
Sure. Yeah, I've been involved in that gold exploration now for the better part of 40 years. And I started off, graduated in the UK, came out here as a backpacker on a working holiday, stumbled into exploration work and ended up working as a fieldy initially. So overqualified fieldy, putting dirt in bags, which I think was a fantastic foundation to start a career. And I didn't intend to get into exploration. It was never my intention, but I got into it and just found it was fascinating. And what I found, though, was being sent out to go and collect samples, which through my training, combination of geography and geology, was I could see that the samples we were being asked to collect, and I could think of one occasion in particular down near Norseman, south of Kalgoorlie, clearly we were collecting soil samples over sand dunes over an old lake bed. And I remember asking the geologist in charge, how is the chemistry from the rocks underneath going to end up in these sands, which are clearly young and clearly have a low cation exchange capacity with minimal amount of clay? How's this process going to work? And he told me to keep quiet and just go out and collect the samples. So that was one of the starts. But what I also got into is just the fascination of gold. Gold being up at Meekatharra, meeting prospectors with gold nuggets around their necks, 3-ounce nugget with this one guy. Met he and his wife, ended up going to their caravan. They had a Nescafe jar full of gold nuggets on the shelf, 2/3 full of nuggets, and he was getting them out and showing them to me. And I was saying, what's this worth? And how much is this one? Whatever. He's saying, Simon, it's not about the value of it. Just look at it for its beauty, its uniqueness. And I looked at it and went, yeah, you're right. It's a pretty special metal. And that's what sort of triggered it. And the love of the exploration, the fun, the adventure of going out in the field, someone to pay to go and travel, someone to pay to go out and camp out in the field and go to amazing places. And that's what triggered the joy. And then the link with chemistry, of course, is we're looking for elements off the periodic table. We need to be using chemistry, but we need to do that in a wise and thoughtful way. So we're not just putting dirt in bags that's got no connection to the rocks. And so it pulls things together that way.
Interesting. I'm just so astounded just to think about the fact that this guy and his wife are just carrying around gold nuggets in their caravan, like no big deal. I'm just admire it for its beauty. Like,
yeah.
you could
Yeah,
buy
wasn't interested
a
in the
palace.
money. Yeah, no, it was just living in the caravan. They were living the dream. They'd packed up, they'd sold their factory in Melbourne. They'd then gone out to the opal fields and sapphire fields in Queensland, carried on round, eventually ended up in Meekatharra, which unpolitely described as the arse end of the world by one of the Prime Minister's wives back along. And I arrived there and wondered, how on earth could anyone like here? And then I got out there. This was in May '86, and I thought I thought the other description was pretty fair, but then I got into it and got to know the locals and got into seeing the exploration side of it, and then meet people that are just passionate about finding gold. One of the stories there, I was going to go and spend a week with them out prospecting and use the metal detector, which I described as inland fishing. You've got to be strong in the arm, weak in the head, and off you go. And just before I left Meekatharra, I went out to visit them, and I changed the car that I had work ute to another one. And when I pulled up, it was a hot summer's evening. They had the hurricane lamp going, and the guy had an automated panning system, and he was panning off the day's collections from the dry blower where they winnowed the dirt, and he was going through the concentrate, and there he had an automated panning system, and you could see the little nuggets coming off one at a time, dropping into a rusty bean tin off the back of it, and they'd hit onto a patch of dirt where the ore bodies weathered out and liberated the gold over the time. You got the alluvial gold that's concentrated, and they'd hit onto a patch of that. So he was looking nervous because he didn't recognize me, and yet he had this, yeah, they'd hit a phenomenal patch of gold. And I realized then that you could have the fun and the adventure of trying to find something, and it could also be financially rewarding as well. But it's really about the chase. It's about the chase and trying to find something that's pretty unique and special.
Oh my God, that's again, that's wild. I've seen drilled into bodies and I've been like, oh my God, that's some free gold in the drill core. But I remember in the Yukon, we had one of the projects I was working on, we had a guy that had a surface claim at the bottom and his equipment just kept breaking and stuff. And he was really angry all the time.
It sounds like a standard driller. Yep.
Exactly. There you go. But they taught me how to pan for gold in the Yukon in Canada, but I never really took off for it with it.
Oh, okay. Yeah. I love going into streams and panning. I've had some pleasant days in Ivory Coast just going around. This was with an Anglo in the mid 90s or so. We spent 2 or 3 days just going around and on a project called Hannah Lobo out in the western side of the country. And every river we went into, we would pan gold out of it and get colors. But you realize then that you actually only find deposits that have got coarse gold in them.
Right.
And you think about the Carlin deposits that were found by Newmont in the 60s, 70s or so. People walked over that ground, didn't recognize it for what it was because they hadn't assay. Yeah. And so at the end of the day, you do need to collect assays. Panning is great. And Kalgoorlie was found by doing that with Paddy Hannon and co. Left Coolgardie and went across to Kalgoorlie, where Kalgoorlie is on the Golden Mile. There's records there of people going around and picking up 1,600 nuggets in a day, specking it off the surface, which sounds absolutely phenomenal, just wild. And I did do a presentation up there some time ago where I talked about it, and it was along the lines of, imagine if Paddy had to send his assays off to the lab, would he have discovered Kalgoorlie or not? But yeah, just that idea that you could be out specking nuggets off the surface. I have done that once. I found one nugget on the surface. We found a deposit near Kalgoorlie, and I was putting in a short survey marker next door to a drill hole one time, and it was laterite gravel on the surface and banging the little stumpy survey marker, and there was a nugget on the surface. So I went out and bought a metal detector that week and then walked around, didn't find any nuggets there, but I found nuggets in other places since, which again, as I said, it's like inland fishing.
Yeah.
Strong in the arm, weak in the head, and off you go.
Also a bit more valuable fishing.
That's very valuable. Yeah, I've still got the nugget and it keeps on going up. That's the beauty net. Yeah, when I found it was worth $300 and today it's worth to it'd be north of $3,000 today, at least a tenfold increase. Yeah.
This is a total side note, but my brother was telling me a financial advisor was recommending him to put money into commodity. I was like, do not buy gold right now. It is so high. Please.
I think it's going to keep going. I think, yeah, all the predictions are it's going to go higher. If anything, silver is probably the one to buy now. The silver gold ratio has got to catch up.
Yeah.
Yeah. Yeah. Interesting one.
Yeah. Anyway, love that. I feel like we've already been talking about some tea, but what else have you brought for us? Kettle thoughts. Let's hear what you got.
Variety of things.
Yeah.
I guess probably along the lines is around what it's like to travel out and go to different places. And it's quite interesting. You start looking at business tourism, I suppose, is one way of looking, but a big part of traveling, being on the international gig, is all the travel. I think we've all gone through the good, the bad, and the ugly airports. And there's some airports I try and avoid. There's one in Africa I definitely try and avoid, where I've gone through that and you've got the money belt with the cash, and
What?
it's gone through and you see the security guys come around and look in your bag, and you think at first it's because they're interested in your hard drives or something like that, or the dongles, but no, it's the money belt is what they've spotted. And then you get taken off to the cubicle and the little hand comes in, wants to take out the 50 euro note or the 100 euro note. I had to raise my eyebrows at them, and then he's taken the 5 instead. That's only happened once, luckily.
Oh my goodness.
Or there's been times when been asked to carry equipment, geophysical equipment. There was a time in Mali, I was traveling between Mali and Burkina Faso, out of Bamako into Ouagadougou, and I don't know whether it was a joke from the geophysicists having a go at a geochemistry person, but they'd been doing some geophysics, and they had a system with a belt that was rigged up, and it had a whole series of motorbike batteries, which are that yay big, and they're rigged up in series with wires on them. So if anything could possibly look like a bomb, this thing looked like.
Right. Yeah.
And I didn't put in check baggage just in case it caused an issue and stopped the rest of the bag. So they'd bought a holdall for me, and I went into the airport and I got through the first security. They didn't think twice about it. And then there was another X-ray machine to go onto the plane before we got onto the Air France flight. And the bag went through, and there were 2 gendarmes behind it, all dressed in military, and they've got their guns on their belts or whatever. And this thing went through. And if anything's going to look like a bomb, this thing would look like a bomb. And the guy didn't even raise an eyebrow. It was like unbelievable. It's just like,
When was this?
this was in probably about October of 95 or so. So it was before 9/11, but still.
Okay.
There was a reason for security even back in those days, but yet they did nothing. So sometimes you get asked to carry things, and I'm cautious around it, but at the same time, though, hey, look, it seems to work out. Yeah.
I know that when I was carrying some stuff, leaving from Vancouver, going into, I guess I was going to Indonesia for field work, and I just had a ton of just different experimental equipment for a volcano. And just the way my professor, who wasn't coming with me on the flight, the way he explained it to me, it's just, you just have to give them more information than they could possibly need.
Yeah.
And then
Yeah.
then it just overwhelms them and they
Yeah.
break. And so when they started asking me like what it was and what it was for, and I was 2 minutes in and they were like, whoa.
Yeah.
Go ahead, you're fine.
Yeah.
Meanwhile, I found that I had these 2 different chemical compounds that were I forget what they were now, but basically, and I don't remember, I think I had them in separate totes anyway, but I didn't realize that they should not have been in the same tote, because if they mixed, they could have exploded. And I so again,
that's
they didn't ask enough questions.
yeah. There was something back along that used to be called zinc zap. I don't know if you've ever heard about that. That was this is pre-portable XRF, and it was something that you used to be able to paint on core, and it would show up very clearly if you got sphalerite in there, if you got zinc ores, and you had to keep the 2 separate. And a colleague from Normandy one time was going out in the field, and they realized that the 2 components, and if the 2 mixed, it could give off a really poisonous gas.
Oh God.
And they had the 2 bottles, 2 glass bottles were put behind the seat of the back of the ute to go out, rattle down this road. And it was only when they arrived at the other end that they realized that luckily that these 2 bottles had been placed next door to each other in the back of the ute. And they could have wiped out the exploration leadership team for a mid-tier miner. And no one had realized. And yeah, luckily it all worked out fine. But yeah, I've forgotten exactly what was involved in that. But it was definitely a near miss in terms of, so yeah, awesome technology, but just be careful about how you.
What are the caveats?
The caveats, yeah. Again, back in the 90s, this would have been early 90s, this happened, and then before health and safety was the thing that it is today, and thankfully it is the thing that it is today.
We don't have to talk about that much.
Yeah.
That's a good point, though. And I think that everybody has their favorites and their hated airports. And whether or not we intend to, we have to spend an inordinate amount of time in them. For me, there might be 3 main carriers in the US that do international flying. So why do you go with American? It was one of the airports that I always have to be into is Dallas, and Dallas is way better than Houston. Or
Yep.
it sounds the same, but Dulles, which is another
Yep.
connecting one. So I'm just like, I would rather fly American based on the fact that I love DC Reagan, that I like Dallas.
Yeah.
LAX, they can keep that one. I would maybe rather San Fran. That's it. It doesn't matter. Yeah. No, it's interesting how then that takes up like priority in like
Yeah.
in your mind.
When I was doing a lot of travel down into West Africa, I'd try and go through Brussels. I'd go through Belgium rather than go through Charles de Gaulle in France, even though that was
Okay.
often many more flights with Air France. Air France is great at losing your bags, delays, air traffic controller delays, but then it's just a totally illogical layout of at the airport. You've got terminals 1, 2, and 3, and then you've got A, B, and C. So if you go through if you're flying at 2C and then go through 2D, you can't actually walk between them. You have to take a bus. And if you get off of the wrong one, as I've done before now, after an overnight flight, you then have to do the complete circuit around, which takes you another 20 minutes to get around. And it's just totally illogical, and it just does my head in. There is now an app that helps you to get through it, but what airport actually should have an app that to get you through? I don't know what the planners were thinking for that one, but that's just
there was no plan.
Totally, there was no plan.
There was no plan.
It all looked really good on paper, but gee, didn't think through.
To translate. Meanwhile, Madrid is fantastic. That's a good airport.
Yeah, I like that one. Yeah.
Look, we can make a whole new podcast about talking about airports. Or I guess we can now talk about what we want to talk about.
Yeah, okay. All right. Let's go for it.
All right. So today's topic, guys. Simon's work sits at the intersection of regolith science, fast geochem methods, and smarter exploration workflows. So whether you're going to be mapping soil variability, running pXRF, or deciding where to send the drill rig tomorrow, the principle's the same. If your sampling is wrong and your data arrives too late, you're not necessarily exploring, but now we're being in the realm of guesswork. So before we get technical, Simon, could you talk to our listeners about why understanding regolith first and designing geochemistry around it has been such a critical part of your exploration philosophy?
Yeah, it comes back from those early days of realizing that not enough work goes into the planning. It's the notion around systematic gridding across the terrain. If you've got a highly variable terrain, you should be changing the techniques as you go. So for instance, the early days, we were doing I was working for a company that had worked out that a 1 kilometre grid spacing across a regional property should be sufficient to be able to detect the footprint of a large deposit, which is fine until you realize then as you come across the terrain. What I found was I could be going out with the air photographs, because it was pre-GPS, we'd be going out with the air photographs to the spots that were placed every kilometre across the terrain, and find that we're going to the top of a hill. Invariably, you'd end up driving across, go to the top of the hill, jump out, collect the sample, get back in the ute again, and it would be fresh rock near surface, let's say, at the top of the hill, because the rest of the regolith is eroded off. And then you jump back in the ute, drive down through the valley, across the drainage at the bottom, and then lo and behold, the next kilometre would be on the top of the next hill. And I'd be looking at that just going, this is crazy. Like, this one soil sample I've collected has probably only actually sampled what, number one, I'm digging into rock. So it's a highly lithic specific sample. And it could be sitting in the hanging wall or the footwall, and I could be 10, 20 meters away from the ore body. But how on earth is this one sample actually going to find that? And particularly if I dig the hole deeper, and the deeper I dig the hole, then the less dispersion that's going to take place. Meanwhile, probably what I should be doing is collecting the drainage sample when I'm going through. So first thing there is that systematic grid sampling is not the way to go. You increase the luck factor. Number two is there's not one method to explore a terrain. It was highly variable. And so with that program there, sure, do the systematic grid sampling, but then also collect a stream sediment sample. And if you're in a deeply weathered environment, then you benefit then from historical, if you're out in the goldfields in West Africa and places like that, you're relying then on deep weathering, rotting of the rocks, liberation of elements out of the rocks up into the profile. Then you get zones of enrichment, zones of depletion, and you then end up then with, you've got the opportunity then to collect, say, a laterite sample. which will give you a regional test with hydrodynamic dispersed elements and concentration. You'd have zones with outcrop, subcrop, in which case then it's very tight, so you need to be doing tighter spacing. You'd have areas of cover. And when you go across cover, then maybe soil sampling is not going to work. So if you've got a good structural target, then you could be sampling the surface. Otherwise, maybe you switch to things like termite samples. You could rely on vegetation for getting elements up to the surface. Or you've got to go, these could be null values, and then we start looking then at doing drilling. And then if we are going to drill, is it going to be deep drilling through the blade refusal? Or do we rely on auger drilling, say, and hitting a specific horizon under the surface? So it's a longer way of saying that the starting point of any exploration program should be a regolith terrain assessment. And that relies on things like elevation models and satellite imagery. And ideally what you're using then is you're actually mapping it. And mapping is absolutely key, because what I found is that people can look at imagery, but it's only when you start putting lines on where you've got a line then that you've got to think about where that line goes. And it's only when you start putting that line on that you're forced to ensure that you understand what the changes are on the imagery. You've got to understand what it is you're looking at. And so mapping crystallizes the understanding, but always have it as a purpose. And the purpose for me is always around how do we explore areas with the least number of samples in the fastest amount of time, and reach that confidence stage of either we're going to do more work or we're going to walk away from a property. There's a bit in there, but that's
there's a bit in there. I felt it though. I felt it though, because it's like, hey, Sam here, are you zoning out or are you actually listening? And in that, I guess what I was really seeing is when I got my first job as a geochemist, as an exploration geochemist, it was down in Chile. And I had some people that were helping me. I had some mentors on the side and everything, but nobody actually there in the sense of hands-on, here's how to do it kind of thing. And I remember Peter Winterburn and some of his students were down. We were working on a project with UBC, and it was a really nice piece of work that Allie Brown did with Peter Winterburn, actually, and Thomas Bizik. Anyway, I remember being there, and I remember him and Allie and Thomas just explaining to me just like these, as you would, it just seems like every Australian anyway, I know you're not Australian, but like every Australian anyway, just takes it to be this ingrained truth about all the different things with geomorphology and all the steps. And I'm just like, oh my God, for the last 2 years, I didn't know that. That was just something that I missed. And so you look back on those original soil programs that I had done and everything, and I'm like, some of it was okay, but some of it was shit.
Yep.
And it hurts, right? Because it's just, I thought I was doing something great. And there you go.
Yeah. The slogan I used to have with the consulting company I had, Regolex, was it's because we don't explore a simple flat earth. And we don't explore a simple flat earth. And we need to, often I say there's 3 components of chemistry. It's the geology first, geochemistry. It's about the chemistry of the rocks. Then you've got regolith. Regolith is around enrichment or depletion, and the landform aspects around physical dispersion. So colluvial soil movements and downstream movements. And the ideal prospector's map actually contains all 3. So you've got geology as the source of the chemistry, regolith enrichment or depletion, and then you need to take into account physical dispersion. For a long time, I was just doing landform regolith maps. I remember having a good discussion at one of the conferences where a geochemist stood up and said, I just need to have regolith maps. We don't need landform regolith maps. We just need regolith maps. And again, no, sorry, you need it for dispersion as well. And without that, you can't make the right call around what sample methods and spacings that you need. And what I didn't realize until later on, and I severely regret in my career now, is I should have been putting the geology boundaries on there as well. And when you've got all 3 together, you've got a true prospector's map, landform, regolith, geology, all on one map. Then you can then be putting your surface chemistry in. you can then be seeing where you expect the chemistry to be on, i.e. it's testing the rocks, and where it's not. And where it's not working just means you've used the wrong technique. So you've done soils in an area where you've got too much cover and too much overburden, and therefore you're not seeing the chemistry of the rocks coming through. And these days, the way I do that one and encourage everyone to do and do the demonstration ones is do pXRF on all your soils. And what you're doing with that then is, as you come across the landscape, you look at how the chemistry of the soils is varying across a magnetic image. And if you're not getting a change in the whole rock chemistry in the soils as you go from a felsic to a granite to a greenstone, then your soils are not collected to the geology. In which case then the commodity you're looking for, if it's not in those, if the whole rock chemistry is varying in line with a magnetic image as you come across the landscape, and you don't have the commodity that you're looking for, then probably they're not anomalous and the commodity is not there. But if that whole rock chemistry is not changing across the magnetic image, they're probably null values, and you haven't actually tested the rocks underneath, in which case then you haven't explored that bit of land. Therefore, then it's probably safe to say that you shouldn't be dropping that ground and you need to go subsurface and use another technique. You've used the wrong technique. And that really is the fundamental principle of what my career has been about in terms of trying to do the regolith landform mapping to end up with maps that enable you to make those calls. And remembering as well that anomalies aren't just high grade assays, it's something you wouldn't expect. And that's what we need to be looking for. We're looking for anomalies, and it's not the highest assays on the out of the assay report sheet. It's
telling a client recently that one of their indicators that they were getting close to something based on everything that we were looking at. I was like, you got this big depletion here. And they're like, okay. And I was like, this is exciting. Is it a potassium over lumen depletion and a sodium high, right? Kind of thing. So anyway, the point was, they're just like, okay. And I was like, no, this is great. This is one of the things you need to be looking for.
Yeah.
And it was just this shocking thing that, like, what?
It's likewise, if you put a target in and they've got a great geological target, and then you have a look at its landform regolith setting and you realize it's out undercover and all they've done is soil sampling. You go, this is a great outcome. This was worth mapping, because what it means is you got null values there. Your target is still live. You haven't killed it. You need to change your technique.
Yeah. Oh, yeah. I love this.
Yeah.
This is fun.
And then, and that's what exploration should be. It is, if it's done properly and using a brain and thinking things through.
Heard. So look, I mean, something that probably a lot of labs don't want to hear though, but you've been extremely vocal about the fact that accuracy perhaps is not the priority in early stage exploration, but precision and detection limits are. So can you walk us through what you think, what this concept is for you, what fit for purpose means for you in practice, and where perhaps are explorers wasting money on assays that at this time perhaps they don't actually need?
Yeah, okay. Couple of things with that one. Fit for purpose. Labs are always focused on accuracy and precision. They rest their names on those, and understandable. They always want to get the highest quality, but hitting the bullseye time and time again. And this is exactly the quantity of this element and concentration in a sample. But in reality, and then detection limit, some people always like to get the lowest possible detection limit to be able to get away from analytical noise. 5 times detection limit, if you get above that, then you're in the clear and you've got clear contrast between background and signal. That's fine, but for instance, and you can get the methods now which are into the parts per trillion levels, and 100 part per trillion cyanide leach Blake results. Awesome. Would I run those on my soil samples? Depends on where I am. If I'm dealing with deep cover, then that's probably what I need. If I'm dealing in a residual soil with some sort of lateritic weathering and some sort of enrichment in it, or just even a standard residual soil in a temperate terrain, I don't need 100 parts per trillion detection limit, because my anomalies are going to be in the hundreds of parts per billion. If I'm out in the rainforest in Ghana, most people don't, or somewhere in West Africa, your levels deposits, the big deposits, big being 500,000 ounce plus, are all screaming. They're in the hundreds of ppbs, if not grams, in the soils. So you don't need 0.1 ppb detection limit. You don't even need 1 ppb detection limit. Lots of companies will define anomalies at plus 50 ppb. And anything below that is considered background. So choose the analytical technique that's fit for purpose for the stage of work you're at. In terms of needing high accuracy and precision, absolutely you need that for resource models. You want to do total analysis in the case of gold for a resource model. Two reasons. One is it's giving you the benchmark that the metallurgist should be heading towards. How much of the ore can they be processing to get the total amount of gold out of it? And the other one then is, as a company is often valued on a multiple for the ounces in the ground. If I was the CEO of a company, I'd rather say that you want to get the total assay on it. So I've got 1 million ounces as opposed to what's actually recoverable, say, which is 90% of the gold. So I don't want to be saying I've only got 900,000 ounces, because the analyst will run $150 an ounce for valuation. Better to run that on 1 million ounces, not 900,000 ounces. So fit for purpose is around making sure we change the techniques, the analytical techniques, the same as we should change the sampling techniques, depending on the stage that we're at, in effect. And in terms of where companies are wasting money, I think it's when people can be very dismissive around portable XRFs because they only want to get 4-acid digest data. Where that can come in, sure, it's awesome having the 4-acid digest. You've got total elements there. But at the same time, though, if you're getting that elemental suite with 40, 50 elements and people aren't using that data, they're just looking at, say, pathfinder elements, they're just looking at arsenic or bismuth or antimony or something as a pathfinder, then why not just do that with a portable XRF and run a limited number of 4-acid digests and do that? The difference is then you can then be getting the results rapidly out there on site, rapidly out in the field, and use something else, use the value of pathfinders to find the commodity for you. And it does frustrate me when I see people, I only want the highest quality data, and you go, yeah, but what's that costing you to get that?
But
What's
also
the
when
impact?
yeah, I hear that. And then also though, what's it too when people are just going to the labs and they're just remember, oh my God, I remember the studies in like the early 2000s with MI and some of those other
Mhm.
ones. So can you talk too about that, where every once in a while industry seems to stick its little
I
fingers
get the
and
silver bullets.
yeah, get a new silver bullet kind of thing.
It's the
Yeah.
silver bullet ones that come on. Those have been a pet peeve of mine. I was actually working with Peter Winterburn I used to report to him in Anglo
Bless
American
his
when we
heart.
set up once upon a time, some time back again. It was around the time when MMI first came out. I'd been watching that development when I've been working for Normandy here in Western Australia in the early 90s. And the claim was that with the mobile ions that they would be able to see up through cover and you could be detecting elements at very low concentration. And I went then and set up the geochem section for Anglo and West Africa. And with Peter, then we designed a whole series of geochem orientation around West Africa, 5 different sites. We put a different size fractions, different analytical techniques, including MMI. And the end conclusion was the only element I really liked out of the MMI was silver. And that's because finally I was getting silver at very low detection limits. I found the reproducibility was phenomenal, but I was getting silver down in the parts per billion level. Gold and silver often goes together, and it's more mobile than gold in the regolith environment. Therefore, it's giving a bigger footprint. And if you get gold and silver together, then you're probably on top of the source. And it was pulling it out nicely on that. But I found that doing a -2 mil or 1 mil was working just as well. And it wasn't worth spending. The conclusion of it was that it wasn't worth us spending the money on the MMIs, both in terms of costs of sending it back to, at that stage, I think it was to one of the labs here in Perth to have it run. And for the limited suite of elements we were getting, we were better off to do ICP multi-elements through a lab in Canada instead to get the multi-elements. But other fads, as I see them, are things like calcrete. Following Challenger discovery in South Australia, they were doing gazillion calcrete samples in the Gawler Craton. Everyone went out there and collected calcrete samples. Meanwhile, I was actually on site at Challenger soon after it was discovered. I was out there with Normandy doing mapping around there. And you walk up on it's a hill, it's like just a little blip in the rest of the flat landscape. And you realize then that it's, hey, look, it's only about 1 meter until you could see fragments of rock on the surface, of saprolite on the surface. And to this day, I've never seen the comparative data. I have seen pictures of Challenger since, and you see it's 1 meter of soil cover, and then you're into rock. I suspect that whilst Challenger's claims as a calcrete anomaly discovery, that a -80 mesh soil or -1 mil would work just as well. But as it was, calcrete was reckoned to be the go. Thousands upon thousands. If you go in the South Australian Geochem databases, like 20,000 calcrete results. People report anomalies all over the place. Some places they drill them and they get gold anomalies out of them. Other places they drill them, they get nothing. But it became apply it blanket fashion, thought it was the silver bullet. I would say the same is happening now with ultrafines. And people applying that.
I've been asked about that. Yeah.
People just applying that blanket fashion. We've done some tests with that between ultrafines and DetectOre and aqua regs, and you find that there's places where ultrafines isn't the answer either. We did some tests where you come off outcrop, subcropping zones and then head out into recent cover. And I expected ultrafines to show the continuity of the mineralization beneath the cover when the other techniques would drop away, and they didn't. All methods died. And that's simply because the cover's too young and it hasn't, or too sandy, it's got too high, there's too many silica grains and not enough clay to be able to take up the metals which are brought up through vegetation or capillary action or the other mechanisms to get metals up to the surface. So again, people relying on that as a silver bullet. Whereas again, if you don't understand the regolith terrain and don't choose your methods and think the answers in the geochemical, in either the analysis, as someone described it to me recently, industry relies on low detection limits to compensate for their incompetence at planning the methods around the landscape.
You bring up so many great points.
And yeah, just defaulting to low detection limits to be that replacement. But because these methods are expensive, they then revert then to doing broad space sampling to cover the areas, which then opens it up to luck, driving to the top of the hill to collect the sample, collecting a sample out of outcrop, subcrop, right? And not thinking about, we should not just be running ultrafines. Maybe we should do some stream sediments. Oh, we're driving over some lateritic material. Let's grab a laterite sample. Oh, we've got some calcrete here. Let's grab the calcrete, because if there is any metal here, it's been brought up through the cover, through the vegetation stream. You've got the calcrete horizon that's come in as an aerosol, drop down into the horizon, form that calcrete horizon in the soil. The plants then are growing down through that horizon. Metals are getting brought up through the plants. The leaves drop off and slowly, organic acids, and then they hit the calcrete horizon. That's then the buffer, and the metals then precipitate out and build up on the calcrete. That's one of the mechanisms by which the calcrete enriches metals, or gold in particular.
Have you written a book yet about all this, Simon?
No, I haven't written a book about this. It's been suggested that I do.
I'm just listening to all this, and it's like,
busy.
yeah, okay, cool. Yeah, this makes sense. I got this. I'm going to forget this. Do you have this written down somewhere?
I've done quite a few trading workshops and things like that, and I'm very happy. I've had a couple of conversations even in the last 24 hours about this. I used to do regolith workshops. I've run them at PDAC and other places. And initially when I was doing those, I used to be cautious about what I'd say, because I was thinking, oh, it's my business. I want to protect what I do.
People want the fire. They want the spice.
And then what I found was, hey, look, you might as well get out there and teach everything, because actually out of a group of 100 people, there might be only 2 or 3 that actually pick up and run with it. And then they still come back, they realize they've only learned a certain amount. and then they'll come back then and talk, and then come back to me for more guidance, which as a consultant was always a useful thing. That's the business side of it. You open up their eyes to what they don't know that they realize they should know. But the other one is that then if you can inspire some people to talk, then they will come back and they think about what they do. They come back to me and ask me questions. Oh, damn, that was a really good point. I wish I'd thought of that. And therefore then I've learned from it. And that's how as an industry we improve. We improve and develop, and we need to do that because there's not enough discoveries made and people waste a lot of money and time.
Yeah, I think the best example of one recently is I have been waiting for years for the Till
Oh yeah.
people from Canada to give
Yeah.
their workshop again at PDAC, and they gave it a few years back, and that was something that I sat there like mouth on the floor most of it. And what I really learned here is that if I'm going to do something with Till, I'm going to need also a geomorphologist to work with me, a quaternary
Yeah.
geoscientist to work with me. That was a
Yeah.
big
Yeah.
takeaway for me. I think you realize to a certain extent, you're never going to be able to know all of the things, but
Right.
understanding the things that you don't know and where you're going to need help with in the future. I think
Yep.
that was a really powerful takeaway for me too. So yeah, when you're ready for that regolith course, I'm ready for it.
Okay, all right. Yeah, no, I will go back to doing that one. I've been in Finland recently in the last couple of weeks at the FEM conference, which then brought back around the importance of quaternary science. What I've been saying for some time is that you've got to look at the landscapes in 3D, but think in 4D. So 4D being time.
Right.
And the big thing in the quaternary landscape, in the tundra, in the areas that have been affected by ice sheets, is like you've had multiple glaciations in the last 100,000 years. So the UK, where I was brought up, in Swansea, where I went to university, we used to talk about the Devonsian, Ipswichian glaciation. So one of those was 25,000 years ago, another one 100,000 years ago, another one 200, 250,000. And in terms of looking in 3D, when I worked for Newmont, I was developing techniques to help geologists to plan their exploration. And a big one there was using elevation models and then looking at on screen with 3D glasses on. So when I do a workshop these days, I often hand out the red and blue, red cyan glasses, and got lots of pictures of people sitting there with nerdy glasses on, but they're all looking at the landscape together. And when you look at northern Canada, for instance, and you take the elevation model of Canada, you can then see where the glaciers came through. You can see the drumlins and the clear shaping of where the glaciers are. You can see eskers on the surface. You can see the kettle hole zones where the ice has dropped out and you've got the sinkhole. Look across into, I've done the same, and on my laptop that I'm talking on here, I've got the whole world at 90-meter resolution topography. And with that, I can turn it on, look in 3D, put all the chemistry back in that one. But when I look across Scotland, for instance, and out through the Lake District in northern England, you can see exactly where the ice sheets came across the North Sea and came around. So imagine that from a sampling point of view. And Canada's a great one. Let's go back to Canada. Beth McClellan and the others from the Geological Survey there, when they're using the tools, they talk about tracing trace elements and minerals for hundreds of kilometers away from the diamond mines. But if you just sampled and you picked up a trace element, unless you put it back in context, how can you piece together the exploration jigsaw puzzle to go, that's the signal, where's the source? And as an explorer, that's what it's all about, isn't it? It's always,
Totally.
let's find the signal, and how do you find the source as quickly as possible?
Heard.
And I would say the way you do that is landform, regolith geology, and time. So look in 3D, think in 4D, and bring those three components together. Then you've got the explorer's map, and then you're using geochemistry properly. And if you don't do that, then you're just looking at numbers. You're looking at a flat Earth, and it's much harder then to build the puzzle and to work out where you've got null values, to be able to threshold your data properly. So you're recognizing true anomalies from just elevated values, and you're not able to use suppressed geochemistry, which can be highly anomalous because the chemistry's had to come up through the cover. So you change your threshold if you're out in the cover area. 5 to 10 ppb could be highly significant, in which case then you do need that 0.1 ppb detection limit. And other places, residual soils, 10, 20, hundreds of ppbs, you can then, don't be distracted by those high numbers. Play the numbers game properly.
Love it. So look, I think a good question to ask now though, and I think especially as we sit here and you're in your office with DetectOre, everything in mining particularly seems to take forever to adopt. We've talked about technologies now that some were just these silver bullets, right? They were just maybe some red herrings in there. But overall, in order for our industry to accept a technology and start rolling with it, it takes a lot of time. Chrysos, for example, took over 15 years. I talked about that with Hugh D'Souza a few months ago, I think. pXRF, as we both know, it has taken decades.
Yep.
So DetectOre, by this logic, should already be pretty standard. Why do you think that mineral exploration, mining, why do you think we're so slow? Is it our culture, lack of training, something else? What do you think?
Yeah, it could be. I think it's a range of all of those. I think there's two speeds in the industry. People won't like to hear it, but you've got the fire in the belly explorers and you've got the lifestyle companies, and you have to separate out between the two of them. If you listen to Rick Rule from Sprott and others, he reckons out of 2,000 companies, 1,800 are just going through the motions and 200 are serious explorers, which is pretty alarming in some ways. So the lifestylers are just raising money and do enough work to be able to raise more money and just keep things ticking along. Meanwhile, then you've got the real explorers. So if I focus then on real explorers, you've then got the issue around ones who are, you've got people that got comfortable with certain techniques and they don't want to stick their neck out and try something different. They go, look, we tried that before, we made this discovery, we're quite happy to run with that. And it's only a smaller percentage of people that are truly comfortable in their knowledge and what they know to go, you know what, this is worth trialing, this is worth doing. And they want to make the discovery. They want to be like Paddy Hannon and go out with the gold pan and go and get rapid answers and make discoveries. So what I've learned now is we pick the champions and we give them the right case studies. So we generated case studies that cover off on their samples and their part of the world. We also offer free trials. It'll cost you nothing. Send us 30 pulps and we'll run those for free. We don't want to know your assays. Just send us the pulps. We'll run it for free. Just make sure you've got no gold, some gold, lots of gold. And we'll run it. And then when we've got our results, we'll swap the results in the ether. That way, then you know that we haven't fixed our assays to yours, and I know no one's sabotaging it at the other end. So we got confidence, and that's because they might sabotage it because they couldn't be bothered. They're only doing the trial because they've been told to, and they'd rather just put dirt in bags and send it to the lab and wait until the assays come back, because otherwise it means they've got to go back out in the field and do more work. But what we found then is when we do free trials like that, that we can very quickly convince people that the method's working. So that then eliminates what they're doing. It starts to move people away from what they used to do to try something different. But some people are just naturally risk averse. Or it's that focus on, I only want the best quality data, and haven't bought into this idea that fit for purpose is right and is suitable. And what we're trying to do, essentially, it's trying to be nimble, like someone going out with a gold pan, but doing that with chemistry behind it. And be able to do that at very low concentration golds, and then use the power of the XRF for all the reasons that people have been using XRF, pathfinder elements, litho discrimination elements, plus alteration elements, and therefore collect objective, fit for purpose geochemical data. And now, of course, we can now put gold, to some extent silver, onto that as well, and do all that out in the field, and therefore then move programs forward rapidly.
And talking about moving things rapidly, you had passed along the keynote speech that you made to FEM, which is a conference in Finland that you did a few weeks ago, and something that you had pointed out, and there's this really interesting table that you had in there on one of your slides. Actually, it's two little tables, and it was about really breaking down the cost of waiting for assays in a way that I hadn't really thought of it before. So could you talk then a little bit about the true costs of delays for assays and why actually getting this faster fit for purpose data could actually change a trajectory for a project?
Sure. Yeah. We took a junior company, for instance, cost around
Mhm.
about $1 million a year to operate. By the time you pay for a CEO, a CFO, stock exchange listing
Mm.
costs running a company, about $1 million a year to run. So if you put that on an annualized basis, about $3,000 a day, each and every day. So if you go and collect a round of samples and you have to wait 6 weeks, that's over $100,000 that you're paying to wait to go back and do the next round of work. If you're working in a place that's got a very seasonal climate, so you're in Canada, let's say, North America, up in or out in the heat of Saudi or in Central Australia, and you've got distinct seasons where you can operate. When you can't work, that $3,000 a day is still clicking through. And so the cost of waiting for assays is astronomical. So if you can only get 2 or 3 rounds of work done in a year, that's expensive. Whereas what we can do now with rapid answers, combination of the pXRF and our DetectOre gold method is in West Africa now we can do 3 rounds of soils, 2 rounds of auger and get an RC intercept in 2 weeks. So you can come through,
That's
you can find the
wild.
prospect, you can
Yeah.
come through, find the prospect, define clear a target. So we use the soils to pull us into the right area. Then we define needle targets and confirm we infill along lines and between lines with soils. Then because the soils are a dispersion where all bodies have lain over time,
Mm.
4D thinking with rotting of the rocks, the deposits formed a kilometre or 2 down or 3 or 4 kilometres down in the earth, but now they're near surface. So all the time the rocks are rotting, the rain's coming down and the ore body's rotting away, mineralization's falling over. That's then giving you your gold nuggets into the soil, the sort of thing that the prospector of Meekatharra was finding. Yeah. And then meanwhile, then you've got this big gold dispersion halo. So what we're then doing is then what I've been advocating for and been using when I was running exploration is then we come through with the auger rig and we poke holes underneath that.
Sure.
And eventually then we want to find the source and then we drill on that. And so by doing the soils, we define really clear soil anomalies. Then we do the auger and we come through on a broad spaces on the auger where we're looking for enrichment in the laterite underneath the surface. And that's where the water table's fluctuated and changes in the EHPH and you get concentration. That's where the artisanal miners go for in West Africa. They'll burrow down through the laterite, get into that redox front. And that's where the nuggets tend to be, leaching from above and concentration from underneath, or just slowly accumulating of metals moving down, something dense, dropping down into the profile. And then so we're augering using that to find the dispersion halo, and then hopefully using the auger then to find where the roots of that anomaly is. And then we come in and bring a drill rig in, hopefully hit it, instead of doing a fence line of drill holes, try and put the drill hole right on top of the source and try and hit it first off. Sample off that. So if you don't hit it with the first hole, move the rig, see if we can hit it, or come back the other way and then hit it. If you have found the source, awesome. You can then got the option then to drill deeper down it, or instead of, let's put it back now, back into plan view in my hand. I've done this a few times now.
Love this.
So this is our anomaly. We used to call it wingspan drilling, right? You want to work out how big is that deposit as quickly as possible. So instead of doing baby steps along an IP image or along map geology, along using geophysics to guide you, or just drilling along the soil anomaly, don't just do baby step outs. You can start doing 160 or 3 meters, 320 meter step outs with the drill rig and be sampling off the drill rig. And eventually then it's going to run out and then you go back the other way. That's how we move projects forward faster. And it's all about let's get the assays out in the field, because otherwise it's stop start, it's mob, demob, bring the drill rig in, do the round of work, because the boards aren't going to release money to enable you to drill. without having confirmation of assays. And chemistry is key to it. And this is geochemistry, the chemistry of the rocks. I'm working with a geophysicist, and I say with a great respect, Peter, it's all very well. Your geophysics is awesome. It can guide the work. But at the end of the day, we're looking for elements off the periodic table. We need to be using chemistry. So let's use the power of the portable XRF, which will deliver fit for purpose data. It will give us pathfinders, some commodities, lithogeochem, alteration. Then couple that up with DetectOre. Now we're using gold to find gold. We're not relying on pathfinders. We're actually measuring gold to 5 ppb with an infill process with technicians to be able to run that. That's how we sprint. We stop the mob and demob.
And so talking about detecting gold straight from your pXRF, like this is new, right? So could you talk us, and not only are we talking about detecting it here to everybody that's listening, but we're detecting it now at sub 10 ppb, which is significant. So could you talk us then through how pXRF has evolved and how DetectOre is really fitting into this broader level of low gold methodologies?
Yeah, all right. So it might be worth just explaining first up why pXRF has never been able to do gold. It's partly around the detection limits. The best instruments, even today on the market, the best they can do is about 3 parts per million. How they've evolved over time, though, is that the sensors have got much faster. The count rates have gone from 10,000 to 600,000 counts per second, which helps to bring down the detection limit. But the limitations are, often show it with my hand here with the gold on it. If you point and shoot off from the window of the XRF, unless you're on top of the gold, you wouldn't be able to detect it. Gold is nuggety. Then you've got that fundamental thing around limited detection limits at 3 ppm. We mine in parts per million, but find with parts per billion. Yeah. Then you've got interfering elements. The main one for gold is tungsten. Gold and tungsten peak are identical in the alpha part of the spectrum. And then you get interferences. You get peak overlaps. They happen for a number of elements, but for gold, it's arsenic and selenium at the L alpha, at the L beta, then I think it's lead and zinc. But you've got interferences, all of which means that you can be zapping a sample in the case of, and you think you've got gold, but it's tungsten off the drill bit, or tungsten naturally occurring in an orogenic gold deposit. And so you get false positives. The method that Mel Linton at CSIRO came up with was putting a sample in a bottle and leaching the metal out and concentrating on a collector device. So you're upgrading. So essentially what we're doing is a leg sample with a pXRF finish. Yeah, that's essentially what it is. I love that. So what we're doing is we're using pouches, not bottles. The CSIRO method was originally a bottle. We're using pouches because these are flat packed. We put a sample in it. The finer the sample, the better it is, the better that the reagent that we're adding is able to leach the metal out. And then ultimately the gold ends up on a collector device, which looks like a tea bag. There's the tea part
I love that.
of the talk. Right? Ends up on this one. This is actually one of our reference materials. I didn't have the other ones handy. And then, so essentially we're doing a Blake sample, we're leaching the gold out, the gold ends up on this, and then this is read on an XRF, where the XRF has been optimized with a focus on the gold method, and the whole lot then is controlled through our software. Comes with the process, but we're leaching the gold using something that's non-toxic, non-hazardous, environmentally friendly, comes as dried powder. It's just as effective at cyanide as cyanide at leaching gold. And essentially, leaching the gold out and concentrating on that collector device. And then that's read by the XRF, and we get gold, silver, and copper leached and collected.
So I have 2 questions to this. The first is, when you're leaching the gold, is it in a sense what happens with fire assay, and now you actually just have like some actual gold that becomes almost to a level where you can take it and sell it and have it? Or is it just so fine? Okay, unfortunately.
It's so fine. No, we don't get the little prills, unfortunately. We don't get the little beads.
When I found out the amount of gold
we can stick in a bowl and then use for the social fund at the Christmas social fund. No, it doesn't happen like that, unfortunately.
Okay, so I was wondering about that. Is it just in the way in which you've manipulated, say, some of the software? How did you guys overcome the overlapping peaks?
That's a great question. That's a great question. So tungsten, we're not dissolving tungsten.
Okay.
So it's not concentrated. So
Oh.
therefore, then that one there is knocked out. So you can run it on an RC sample,
Uh-huh.
whereby we're just sieving the fines. The fines have been created all the way through the meter. Again, use my knuckles as like the knobbles on an RC hammer, and it's been pulverizing all the way through the meter. Then we sieve, because we can't leach gold out of the chips and fragments that also come out of the hole. Just concentrate the fines and put those in the pouch and leach off those. Sieve to -2 mil or 1 mil. So that's how we deal with the RC samples, but it doesn't matter if any of the tungstens come off, because even if it's in the fines there, it's not being leached, so it's not ending up on the collector. Arsenic is the other main interference metal. Two ways we deal with that. One is we're not getting much arsenic onto the collector, so it's not causing a peak overlap. Our software will monitor what other metals are on if there's any of the interference metals on the collector device. And if we picked up there was high arsenic, it automatically flags that and goes to the other part of the spectrum where gold occurs, and we'll do a reading there. And then it'll then report the gold value based on that other part of the spectrum, where everything is calibrated. Everything is calibrated. So it doesn't affect the result. It's just that the noise to signal isn't as good at the other part of the spectrum.
Right.
So,
oh my God.
yeah.
That makes a lot. Now I'm thinking more about myself and things that I'm interested in. But yeah, that makes a lot of sense. Yeah.
And then because for diamond core, of course, diamond core, we can't be putting sticks of core into the bag.
No,
so what we do then is when the core is cut, we capture the sludge that comes off the core saw.
Oh.
So yeah, if you're using a brick saw, we use a Bain Marie tray, sort of thing you use in catering, seen in big catering trays with the steam underneath them, the steam baths underneath, and it's keeping the food warm. Anyway, we're using one of those big stainless steel catering trays, goes just underneath the carousel, where if you've got a tile saw or brick saw in this part of the world, just control the amount of spray that's coming off the blade, and then capture the fines coming off that. And just behind me here, there's an example of a drill hole in Zimbabwe, where a company called Ariana Resources ran it, and they cut the core. They collected the sediment and ran it. This in rhyolites and dacites with speckled sulfides all the way through the hole, and they DetectOre's nailed every interval that's got gold in it. And the chief geologist came in and he said, "Look, honestly, I thought this was bullshit. I didn't think the method was going to work. I only did it because the CEO likes to get gold, that likes to try new techniques." Held out his hand and said, "Congratulations, Simon. You guys have got a game changer here."
Love that.
And all they've done, they ran it, they took the instructions, they taught themselves how to run the process. Over there in Zimbabwe, they use local staff to run the process. So the spray comes off, goes into the Bain Marie tray, the water gets poured off, and then we use a cake spatula. One of those bendy cake spatulas, and you scoop the slop out, put it in the calico bag, just allow it to drip dry for a while. You don't have to dry it fully. Split that out, and then put 100 grams, 150 grams. Meter of NQ core gives up to 250 grams of dried sediment per meter, material that normally is thrown away.
Yep.
And now it's being used for something useful. And that way then can be getting gold results whilst the bit is still down the drill hole. So don't rely on alteration, rely on chemistry to make that $10,000-$20,000 decision whether you're going to do a wedge, try and get a second piercing or third piercing into an ore body that you might have drilled for the first time. Don't just rely on alteration. Be guided, guiding gold exploration, not just relying on pathfinders or indicator metals.
That's really interesting.
Pretty powerful. And that literally has been, yes, someone went and looked at their setup recently and described it as fairly agricultural, but it might be agricultural, but gee, it works. And they reported those results to the London Stock Exchange in terms of putting out the case study and sold on it, which is neat. Yeah.
I think the whole case study is really neat. And it's one of those things that you're just like, you're sitting there probably just being, I know this is going to work. Like I know my tech, but at the same time, it just being so rewarding to have somebody just be like agog over it. I can't believe it. And congratulate. That just must be unbelievably
Uh,
rewarding.
it's so nice. Yeah. The way I ended up going to Finland recently was I went to the School of Mines last year. Soraya, the professor of applied geochemistry at Oulu School of Mines. I turned up there last February and he had about 15 bags of dirt, which were coarse rejects on the bench. And he said, Simon, tell me tomorrow how much gold is in, go and choose 9 bags and let's do one duplicate. I ran those through the process. Luckily, the duplicate I chose it turned out to be a 50 ppb sample, and we got 42 or something and 50 something on that one. And the highest result was 70 ppm, and we got 52 ppm or so in a short time out of it. Anyway, again, he held out his hand. He's quite a big fellow and held out his hand and shook it and said, congratulations, this is a game changer. Yeah, which is nice. But sometimes it is frustrating that I think every project should have it already, and it's not just me from a commercial aspect. It's just around if anyone truly has the gold bug and wants to explore and make a find to find gold, why on earth aren't they using us? Why people say, aren't you being run off your feet with doing things, selling the products around the place? The reality is we are busy and we're getting repeat orders. And we've sold into 36 countries and helped with 3 gold discoveries in the last 3 years. We've been attributed with 3 gold discoveries. So clearly it's working. But no, we're not. We're still having to convert people. We're still dealing with that industry skepticism about a new technique and a new process. And for me, sometimes it's a bit inexplicable other than thinking back. I've been trying to get people to do regolith mapping for all my career and saying that should be the precursor and the starting point to things, and just realize that just not everyone has that fire in the belly to make a discovery. It's a job for them.
It takes a bit of an audacious person to make that leap to it. When I think about it, it's when you're young, sitting in a room, right?
Yep.
You feel like you don't have a voice. So there's that.
Yep.
You come maybe middle of your career and then you're just tired of everything and everything's pissing you off and you just want to get home at the end of the day. And then maybe you're late in career and you're just like, what's somebody else's problem? So now we've just described 3 different stages of the career. And I think I think really what it comes down to is that it can be somebody at any stage in the career, but it has to be somebody that just has that natural curiosity, and that doesn't always come around. It doesn't make other people like bad people necessarily, that they're not curious and they don't want to try things. But then it's depending on the stage of your career, who can you get to bring along with you? You're talking about the people behind you with their CEO who made the geologist try it, right?
Yeah.
Sometimes it takes those kinds of CEOs to push things down. I found a lot when I was working in hyperspectral imaging, the problem a lot of times is that it did come from the top, but the problem was really that I had to deal with all the geologists at the lowest levels. And it's not because they weren't smart that I didn't want to deal with them. It's just they were so busy with everything else that they had to do that they had no time to invest in what I was trying to get them to see, the incredibleness that was happening. But they're like, I can't right now. So it's hard.
Have you ever seen that cartoon? There's a cartoon of there's a king. You've got a load of it's set in the Middle Ages, and you've got a king there with a bit of a tent, and you've got all these guys dressed up in armor plating, and they've got their big spears and things like that. And off to one side, you've got a sales guy, and the caption is, I've got a guy that really wants to talk to you. He's got something that's going to help you greatly. And he said, no. And the king's holding out his hand, going, no, I'm really busy right now. I've got a battle to go and fight. And the guy's standing there next door to a machine gun, right? Yeah. And I feel like that sometimes. We've got the machine gun that will enable them to just blitz the property and to explore really quickly. And people are going back literally with doing what they could have been doing 20, 30 years ago. And it's because they're too busy to stop and look at what else could be done. And I was on a panel recently, the Exploration Managers Conference at the Amara one, and I held up that one on a panel session talking about industry issues and problems. And it is that one that people get too busy in their day-to-day thing that they do not step back and then make the time to learn something new. It'd be like if you're only ever writing notes and then suddenly you think, oh, maybe I should have a look at one of these computers and I should have a look at the computer and start to learn to use Microsoft Word. Wouldn't that improve my workflow? Oh, I should stop sending letters by post. I should start looking at this email thing. How would that help? Or another analogy is go back to pXRF. I've had people tell me that, oh, I tried pXRF 15 years ago. It didn't work. I thought it was crap. And you go, yeah, back in those days, I was using a Nokia phone. I was trying to send text messages and I had to press to send C, I'd have to hit A 3 times and then that one there. You know what? I've still got a phone in my pocket. I can still make phone calls, but it's no longer a Nokia. I've got my iPhone. It's still a phone. Yeah. The pXRF has moved on in the same way. So people get with it, right? Don't just brand it as one thing or think you've tried it back along. Just move ahead with the times and keep an open mind on things.
Keep an open mind.
Keep an open mind and make the time to learn something new and try something different. Yeah, I think I think the thing that moves things forward, I know in my career, the biggest one that made a difference is once you reach that stage where you have confidence in what you know and you're confident enough to speak out and you know the consequences are not terminal, i.e. if you do speak out and do upset someone, the worst thing that can happen is to lose your job, let's say. But if you're in that position where it really doesn't matter, it's not arrogance or whatever, it's just it's having that confidence to speak out and speak out with the view that if it's a great idea, put it out there. As Greg Hall used to say this with Placidome as chief geologist, he said, look, if you've got a great idea, put it out there, because it's better off that someone shoots you down and you realize that what you're thinking is bullshit. You're better off learning that sooner than later. And they come up with a reason why your great idea isn't such a great idea. The better you learn that, the better you'll move forward without being wedded to that one idea. And if you have put that out early on and it is a great idea, then that's fine. It's nice to be tagged with that yourself, but at least you haven't gone down the wrong path. And that's where often I think the industry fails, is not sharing enough information, not collaborating enough, and not working together to solve common issues.
I've said this 1,000 times on the show, but it's, to me, the greatest failure of our industry at this point is that we put more value in data than we do in our people. And you can see it in the many rounds of mass firings and layoffs and everybody moving around because nobody's happy here, there, or whatever. It's just until the people that run our companies recognize that our thoughts and our ideas have value, it's impossible for all of us as an industry to really move forward in this, because every time that somebody leaves a company, the value, say, of a great idea or their experience, say, of using this new gold technology, it gets lost because nobody's going to pick it up from them. But that same idea will go to the next company where they can benefit from the 5 years, say, that it's been developed in somebody else's house, but now it's gone to another company.
Which is where I always say with the majors or whatever, we get into the majors as we have, then people leave those companies and end up in the different companies, and slowly then it will spread and you slowly get the osmosis or network effect happening. And it spreads out that way. But another one of my soapboxes always also around the inefficiency in that the industry doesn't collaborate enough between companies. Always think it's a competition between Barrick and Newmont or Goldfields and Evolution or whatever, whereas in fact the reality is it should be an industry. It's the gold industry, it's mining exploration versus marijuana and crypto or banks and telcos in terms of competition for capital. And unless discoveries are made and things are efficient, then money will go elsewhere. And boom times, the industry comes to a grinding halt because the labs have never got enough capacity, have never built enough capacity. So at the height of the boom, no one's getting assays. No one's able to do current news releases. there just isn't enough information flow, so capital gets tired and it will go somewhere else. And so what we're doing now is building systems and processes so we can be the antidote to the lack of labs. And that's why the big labs are adopting us. So we're in the product guides of ALS and BV, got MSA labs also picking up and running with us. ALS are running us for grade control. So the big labs are seeing the benefits of it.
Yeah.
And we'll start adopting it, but it's vital, particularly as we talked before, gold at near record prices. The labs are filling up. When people start waiting for assays, realize they don't have to keep sending samples to the lab, that there is another way of doing things. And I think this time around, the boom can be different. We've scaled for that and are ready for it.
Simon, thanks so much for joining us here on GeoChemistry. Everything that we talked about here range from insightful to iteration of things that we needed to hear again to just a lot of times we'll talk about tech on the show, but it's not often sometimes that we have people that are actually on the forefront of trying to adopt a new technology. So thank you for coming to talk to us with this. I also want to thank our sponsor, LKI Consulting, and to It's Water and Coma Media for our music. Thanks to everybody for turning in. Everybody keep asking questions. Keep mapping your regolith, and as always, keep the tea hot. So see everybody next month.
Thanks very much.